Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 3.2, which is going to deal with understanding relations and functions. So for today, we only have one learning goal, and our learning goal is you will be able to identify the domain and range of a relation and determine if it is a function. So we're going to take a look at what a relation is, identify domain and range, and then state whether or not it is a function. So that is our goal for today, and hopefully by the end of the video you feel comfortable with that. Alright, so let's get into some terminology, and we'll kind of go through and explain different parts from there. Alright, a relation, so that's going to be the first thing we're going to look at. A relation is a set of ordered pairs, x comma y, where x is the input and y is the output. The domain is all the possible inputs of the relation, and the range is all the possible outputs. Okay, so domain is the inputs, or the x values, and the range is all the outputs, or the y values. For example, the given relation represents the number of whole wheat cracker boxes sold and the money earned. So this is our relation. Okay, a relation is a set of ordered pairs, meaning 1 comma 4 is our x comma y. So 1 4, 2 8, 3 12, 4 6. So know this, a relation is just a set of ordered pairs. Now, when we talk about the domain is all the x values. So if we look at all of our x values in the relation, okay, 1, 2, 3, and 4, those are my domains, because domain is the x. So this is something that's really helpful to keep in mind. Domain is x, and range is y. So if all my domain values are 1, 2, 3, and 4, because those are the x values, my range values are 4, 8, 12, and 16. And it looks like there's a slight typo there, because I have it as 2, but this should be a 4. So my domain is 1, 2, 3, 4, because 1, 2, 3, 4. My range is 4, 8, 12, 16, so 4, 8, 12, and 16. Alright, so that is what a relation is. A relation is a set of ordered pairs. Domain is the x values, and range is the y values. Now, a function is a type of relation which there is only one output value for every input value. So for every input, there is a unique output. So that's what this new part here says. So to identify if something is a function, kind of an easier way to think of it, and I'll highlight what it looks like in different representations. But you cannot have the same number listed more than once for the domain. Okay, if I look at my relation here, so I have 1, 2, 3, and 4. Did 1, 2, 3, or 4 ever repeat when I listed off the x values? It did not, therefore it would be a function. So a function just states that you cannot have the same input or x value more than once and get out a different result. So when we're going through and determining something as a function, as long as x is not listed twice, then you have a function. If it is listed twice, you do not have a function. Alright, so with all of that said, example 1 is going to ask us to go through and represent the following relations as a table, a graph, and a mapping diagram. We need to find the domain and range for each relation and determine whether or not it is a function. So that's going to be our goal for example 1. I'm going to move this up so that way we can kind of take out all that extra stuff. Alright, so like I said, example 1, we need to go through and represent our relation that they give us as a table, a graph, and a mapping diagram. So we have a table, we have a graph, and then we're going to talk about a mapping diagram. Then we're going to look at domain and range, and then determining if it is a function or not. All right, so for A, for the following relation, the input x is the age of boys, and the output is their corresponding height in inches. So my relation is 741, 845, 949, 1052, 1053, 1155, and 1259. So the first thing we're going to do is a table. To do a table, okay, the first number in your ordered pair is your x, and the second number in your ordered pair is your y. So x comma y, meaning I need to go through and list all my x values and then their corresponding y values. So my first ordered pair is 741. So x is 7, y is 41. My next one is 845. And then we're just going to go on down the list. So 949, 1052, 1053, 1155, and 1259. And that is how we're going to represent our relation as a table. So that succeeds the first part, so creating a table. The next part is going through and creating a graph. So for our graph, we're just going to take our table or our ordered pairs and plot each of the points. So our first point is 741. So we're going to go over to 7 and then up to 41. And I'm going to give an approximate location for it. So right there. And then we're just going to go through and plot all the other points. So 845. Then we have 949. We have 1052. And then 1053. Oh, I went 1, 2 over. So ignore those. I have 1155, so right there. And then 1259. So 1259 is going to be right there. So outside of my mistakes right here, okay, the red dots are going to represent all of these ordered pairs here. So this is my graph representation of my relation. Now, mapping diagram. To do a mapping diagram, there's a few rules. First of all, okay, we're talking about age in years here, and heights in inches here. Well, that relates to my x and my y. You're going to set this up very similar to a table, but the key thing is this. On either side, if a number repeats, okay, so in the case here I have two 10s, you do not write 10 twice, okay? If you're taking a quiz or a test and you happen to repeat the number on one side, okay, a table we can repeat the number 10. In a mapping diagram you cannot. So if we're going to go through and list all the x values, okay, for a mapping diagram it would be 7, 8, 9, 10. And unlike here where I have two 10s, again, we're not going to write it twice like we did in the table. We're just going to go on to the next one. So 11 and then 12. And then we're going to do the same thing for height in inches. So we have 41, 45, 49, 52, 53, 55, 59. So none of those repeated, so I can go through. All right, so that is not my complete mapping diagram. A mapping diagram wants us to go through and map what numbers match with their other parts. So if we go off the relation, so it's 741. Okay, here in a table, I know that 7 correlates to 41. So in a mapping diagram, we're going to draw arrows from the numbers on the left to what they match on the right, or what their corresponding part is on the right. So 741, 845. So we're going to draw an arrow from 8 to 45. 949. 1052. 1053. 1155. And then lastly, 1259. And that is our mapping diagram. All right, so I have gone through and demonstrated it as a table, a graph, and a mapping diagram. Now I need to go through and find the domain and range. So let's go through and list our domain and range for this relation. So up above, I talked about the fact that domain is the x values and that range is the y values. Now, there's a couple different ways we could go through and discover domain and range. You can go off the relation, you can go off the table, you could use your graph or the mapping diagram. I find table is the easiest because if domain is the x, well, I already have a list of x values. And if range is the y, I already have a list of y values. Now, you could do the same thing with a mapping diagram, and it might be a bit better to use, because the key when you write domain and range, again, do not list a number more than once. Okay, so you could really go off the mapping diagram. Again, do not repeat a number more than once in domain or in range. So, if I have 7, 8, 9, 10, 11, 12, that means my domain is 7, 8, 9, 10, 11, and 12. You can use the table as well, just know that you cannot repeat 10. Doesn't matter if a number from here, say 12 was over here as well, that doesn't matter, it just matters in the same column. So range is 41, 45, 49, 52, 53, 55, and 59. So 41, 45, 49, 52, 53, 55, and then 59. All right, so I now have my domain and range listed, and that, for most part, goes through and accomplishes my part for this outside of going through and determining whether or not it is a function. So to determine if it's a function, let's talk about a couple different ways to do this. First, you could look at your relation. Okay, again, we are only looking at the x values. Is there any time that a number for x repeats when I list them off? 7, 8, 9, 10, 10, 11, 12. Did any of those numbers repeat when I listed them off? Okay, you should have heard one repeat. Another way we can look at is off the table. So I have 7, 8, 9, 10, 10, 11, 12. Well, 10 is listed twice, just like I listed 10 twice there. You could look at the graph if there's ever a dot that matches up vertically, like here for 10 at 52 and 53. Or, one more way I can do this is if I look at a mapping diagram, okay, what I want you to do is ignore the right. Okay, if we look at the left side, is there any number on the left side that has more than one arrow coming out of it? Okay, 7 has one arrow, 8 has one arrow, 9 has one arrow, 10 has 2 arrows, and 11 and 12 have one. Because 10 has 2 arrows, it has more than one arrow coming out of it. That would be not a function. I don't care if all the arrows go to the same number on the right. It only matters if you have more than one arrow coming out the left. So, because 10 was listed twice here, you have them matching up vertically, and you have 2 arrows coming out here, Okay, you don't need to go through and do that for all 4 parts. You just need to use one as a reference, and that's going to tell me that this is not a function. So our answer for that one is the relation is not a function, thus completing that part. All right, so the rest of example 1 is kind of going through and doing that, where you're setting up a table, a graph, and a mapping diagram, and then determining domain and range, and then if it is a function or not. All right, so I'm going to kind of go through a little bit more quickly for the other parts. I do want to do them so that way you see an example of it, you have a reference. If you feel comfortable with it, you can kind of go on to example 2 in the video, but otherwise keep paying attention because there is some helpful information. All right, for B, I have my relation of -2, 5, -1, 1, 3, 1, -1, -2. So if I'm setting up a table, it would be -2, 5, -1, 1, 3, 1, and then -1, -2. All right, so that is my table. If we're then going to go through and graph these, and my graph would be -2, 5, -1, 1, 3, 1, and then we have -1, -2. All right, so that's my graph representation. And then if I go through and set up my mapping diagram, again, x on the right, y on the left. So if we go through and list our numbers, so I have -2, -1, 3, -1. Again, I have -1 listed twice, so I'm going to write it once. So -2, -1, and then 3. And then for the right, for my y's, I have 5, 1, 1, -2. 1 is listed twice, so I'm going to have 5, 1, -2. All right, so to go through and set up my mapping diagram, -2 goes to 5, -1 goes to 1, 3 goes to 1, and then -1 goes to -2. And that is my mapping diagram. All right, so if we are going through and listing domain and range, okay, again, domain is the x values for my relation. So it would be -2, -1, 3, and -1. Well, I already have -1 listed, so if I use my mapping diagram, it's -2, -1, 3. And then for my range, I have 5, 1, and -2. Yes, there is another 1, but we only need to list it once. And I have my domain and range. Now, this is a great point to talk about from something I mentioned in A. Because domain and range is x and y. Okay, you're only going to look at like the x or the y values. It doesn't matter the fact that I've already listed -2 for the domain, and I can also write it for the range. Okay, so don't think just because I already listed it once, I can't list it for the y values or the range. It's only you can list it once for the x, and you can only list it once for the y. So you can only list it once for a domain and once for range. All right, my last part on this is determining whether or not it is a function. Okay, again, you can do this from one of 4 ways. If we look at our list here, so -2, -1, 3, and -1. So if we look at our table, I don't care about the y's. Is there any number for the x that is listed more than once? So -1 is repeated. Because -1 is repeated, that means it is not a function. And something I want to talk about with our mapping diagram. It does not matter the fact that 1 on the right side has two arrows going to it. Okay, again, I don't care about the right side. If we focus on the left side, is there any number that has two arrows coming out of it? Okay, we have -1, like I mentioned over here. So either one of those checks will tell you if it's a function or not. So I know that this is also not a function. I do promise there are some that are functions out there. And that is part B. All right, for C, we're going to continue the same thing, and I know you might be feeling it's redundant, thinking the notes are going to go forever. I promise example 2 is going to go a lot faster, so that's why I'm doing every part of example 1 for us today. All right, let me get this lined up. So example 1C is going to follow the same idea, where I need to go through and express it as a table, graph, and mapping diagram, identify domain and range, and then state whether or not it is a function. So let's go through and set up our table first. So we have 5, 3, 4, 3, 3, 3, 2, 3, and 1, 3. So we're going to have 5, 3, 4, 3, 3, 3, 2, 3, and then 1, 3. All right, so I now have my table for my graph. Okay, it's 5, 3, so over 5 up 3, 4, 3, 3, 3, 2, 3, and 1, 3. All right, so that is my graph for that relation. And then if I want to go through and do a mapping diagram, again, x and y. So my x values, I have 5, 4, 3, 2, 1. Okay, none of those repeated, so it's just 5, 4, 3, 2, 1. And then my y values are 3, 3, 3, 3, 3. So it's all threes. I'm not going to repeat them, so we're just going to write 1, 3. Again, I have to draw arrows going from the left side, my x, to its corresponding part on the right, the y. So 5 corresponds with 3, 4 corresponds with 3, 3 corresponds with 3, 2 corresponds with 3, and 1 also corresponds with 3. So that is my mapping diagram for this relation. Now, before we get into if it's a function or not, let's state the domain and range first. Again, domain is the x values. I'm going to go off the mapping diagram. So all my x values for the domain is 5, 4, 3, 2, 1. Sometimes they want you to put them in order. If they do that, put them in order. So we have 5, 4, 3, 2, 1 is our domain. And then our range is our y values. Well, we have 3. I'm not writing 3 5 times because that's repeating and we don't repeat. So my range is just 3. All right, so the ultimate question, is this a function or not? Well, let's kind of go in reverse direction when I check them. If we look at our mapping diagrams, again, I don't care if all the arrows go to one spot on the right. Okay, that's not my concern. If I look at the left, is there any number on the left side, say 5, 4, 3, 2, or 1, that has more than one arrow coming out of it? Okay, they all have one arrow coming out of it. That means it is a function. Okay, my graph matches up, and my table does as well because there's no numbers listed for x more than once. Same as here, so 5, 4, 3, 2, and 1. Because those are not repeated at all, that means it is a function. So we finally got a function. Some of them are a little more clear because it would just be a straight across arrow for them, or they might correspond to one other. Key thing to know, number cannot be listed more than twice or more than once for the x values. and you cannot see more than one arrow coming out of number on the left. All right, so that is example 1. I know that's probably the most amount of time we'll spend on an example. And I know I went through all 3 parts, unlike normal, but I wanted you to see different scenarios for mapping diagrams, domain and range, and determining if it's a function or not. Most of you should feel fairly comfortable putting it in a table and in a graph. It's really just mapping diagram, domain and range, and function is new for you today. All right, so with that said, I have one more example and one more concept to talk about, and it's going to be using graphs to go through and determine if something is a function or not. So that is what this part is here. In previous math classes, you might have talked about a vertical line test. Okay, so a test called the vertical line test can be used to determine if a relation is a function. The vertical line test, so that's what we're going to use, states that a relation is a function if and only if a vertical line does not pass through more than one point on the graph. So I'm going to move this up so we can look at all these. So this is example 2. They want us to use the vertical line test to determine if it is a function or not. So if we look at our first one, first of all, vertical line is straight up and down, like this. Okay, so my pen is a vertical line because it goes straight up and down. Horizontal is straight across left to right. Okay, so think about the horizon. Okay, horizon, horizontal is straight across left to right. Vertical is straight up and down. Now, you can do this using your finger, a pencil. Heck, if you want to use a ruler and go through and do the vertical line test, you can do that. So, vertical line test states this, and let me cover up these bottom ones so we're not distracted by them. The vertical line states this, is if I take a vertical line and I run it left to right, if at any point the graph touches this vertical line more than once, it is not a function. If as I move my vertical line across the graph left to right, it only touches the vertical line once, all the way across, then it is a function. It doesn't have to be the same point, it just cannot be touching it twice at one time. All right, so if we do that, okay, if I move left to right on this, okay, if we keep going across, just to kind of identify, so right now, my graph is touching this point, but it's not touching any other point on my vertical line. So as I keep moving across, it doesn't matter if the position it touches moves. Okay, I'm not getting it to touch at any other point. If I keep moving across, it never touches that vertical line more than once. That means this is a function. So, a little space here. So, first one is a function. All right, so if we look at our next one, so if I take my vertical line and I move it straight across left to right, well, as I get going, okay, my graph touches here and here. Because it touches at the same spot that my line is twice, so here and here, that means it is not a function. It has failed the vertical line test because it touches twice at the same spot as I move left to right. So this is not a function. Again, it's not a function because my graph right now is touching this vertical line twice at the same spot. Same spot does not mean it has to cross at the same spot, but just that it crosses the vertical line more than once. All right, so if we then do that for the last 2 parts, okay, if we take our vertical line and move it straight across on the circle is also going to fail the vertical line test because it touches here and here, and really throughout as we go across. So a circle is not a function. It's a relation, but it's not a function. And then lastly, for my graph right here, this gets a little tricky because at first, we're doing good. This is where it gets a little dicey, but it never does cross more than once. Therefore, my cubic function, or my cubic equation or graph, is a function. So, use your vertical lines, whether you want to go through and use a pen, pencil, piece of paper, or if you want to use a ruler. So what you're going to do is take that vertical line, run it straight across from the graph, and then see if it ever crosses the graph more than once at a time on that vertical line. And if it does, it fails the vertical line test and it's not a function. If it is okay and it passes the vertical line test, then you have a function. All right, so that is our lesson in our video for today on section 3.2, which is on relations and functions. So thank you guys for listening, and if you have any questions, be sure to shoot me an email or ask me next time you see me. Also, be sure to use the completed notes as a reference when you go through the homework. But otherwise, that is your notes for today, and I hope you have a great day. Thank you for listening, and talk to you later. All right, bye.